Welcome to the Ideal video series on frequently asked questions. This is a series of short videos to explain how to approach common scenarios, model specialized BMPs, or troubleshoot typical issues. Today's video is about how to use Ideal to demonstrate compliance with the anti-degradation standards. The Ideal model is a tool used to design and calculate pollutant removal efficiencies of BMPs and treatment systems. Water quality standards are determined based on location and the nature of the development or redevelopment. Ideal is suitable for demonstrating compliance with nearly any post-construction standard. A pre-development versus post-development standard is discussed in this video. A pre versus post water quality standard is when you are comparing the post-development loading of a constituent to the pre-development loading, and usually ensuring that there is no net increase, though some allowable decrease or even a required decrease are also possible forms of this type of standard. This standard requires the designer to create two separate model scenarios, one for the pre-development condition and one for the post-development condition. These can be done in a single model file if you choose to, or in two files for quicker run times. Either way you set it up, the first step is to model the same total area in the pre-development model and the post-development model. Let's look at an example in Ideal. For easier viewing in this demo, our example model contains both the pre- and post-development scenarios in the same workspace. If you want to take this approach, make sure you name the objects clearly to eliminate confusion when reading the reports. As you can see, the pre-developed site is modeled on the left side of the workspace with no water quality treatment objects, and the developed site is modeled on the right side with a bioretention cell BMP. We will use this model as an example for this discussion. Before running the model, let's check a few important things. Open the storm inputs by double-clicking on the storm cloud in the top left of the workspace. Make sure that you have the correct location set and the annual probability distribution of storms selected. You must run the annual storm event for both your pre- and post-development conditions. Next, let's validate the model. Validation successful, which means there are no input errors in your model. Now, click Run. This could take several minutes to run depending on the complexity of your design. Again, if your model is taking a long time to run, you can decrease the runtime slightly by modeling the pre- and post conditions separately. After the model runs successfully, view the results. The results you will need to compare can be found under each outlet section in the report. This is where your naming conventions will come in handy. First, make sure the total modeled area is the same for pre and post. It is easy to forget to subtract the BMP area from the sub-watershed area, so this is a good way to double check that. Then, compare the total constituent loads to determine compliance with the annual loading standard for the pollutant of concern. Thank you for using Ideal. As always, if you have any questions about Ideal, please contact the StormOps support team at info@stormopssoftware.com. Also, visit our website and follow us on LinkedIn to get the latest news on support and new releases.